Looking at domain 7, which is operation security, is a fairly small domain as well. However, one thing I can tell you right in the beginning, if you want to write the exam and you do have experience in the mainframe environment, working on the bridge, support systems, and so on, that will help immensely. Let's look at the requirements and definition from the Candidate Information Bulletin from ISC Squared. It says that security operations domain is used to identify critical information and the execution of selected measures that eliminate or reduce adversary exploitation of critical information. It includes the definition of the controls over hardware, the media, and the operators with access privileges to any of these resources. Auditing and the monitoring are mechanisms, tools, and facilities that permit the identification of security events and subsequent actions to identify the key elements and report the pertinent information to the appropriate individual, group, or process. The candidate is expected to know the resources that must be protected, the privileges that must be restricted, the control mechanisms available, the potential for abuse of access, the appropriate controls, and the principles of good practice. Well, knowing that, let's start. The domain objectives here, we're going to look at administrative security as well. As you know, within your environment, there's a few administrators looking after systems as well. Now, those should be limited to only a few that is required for the administrative purpose as well, and no more. The protection and control of data processing resources such as media management, backups and recovery, and also change control. Privileged entity control, that's quite a big important one. Again, who's looking after your network, the hardware, the operating systems, adding users and removing users and so on. So we need to look at that. People with special privileges, and then certain categories of control around that as well. Now, from an administrative security point of view, privileged entity controls. So we'll look at from that, who has privileges and what can we do about that? How should they be monitored, or should they be monitored? Separation of duties. For example, a maker and an authorizer should not be the same person. That means a capture of a transaction and the authorization or the release of the transactions. Once you have the same person doing both, you actually open the door for fraud and abuse. Rotation of duties or job rotations. The advantage of this when we do it is that it can identify a fraud. Somebody else can pick up what another person was doing if he was committing something outside the acceptable use. Non-disclosure is very important here as well. So an administrator as well usually has access to data which is not normally part of his job, purely because of his access or the power of the account. So non-disclosure agreements control and ensure that you can take action if any data is disclosed using unauthorized means as well. Background checks, very important for administrative purposes as well. So if a person has got access to your system outside the normal business processes, you need to make sure that that person can be trusted as well. Now, it can be from a company that supplies staff, it can be from HR, and it can also be from management as well. So background checks is very important, police clearances, credit checks, and so on. Configuration management from a system point of view, we'll look at that. And then finally, change management as well, and what we need to do that from a change control process as well. Now, facility support systems, as within the physical security realm, the support system in a centralized or decentralized operations environment must be protected as well. Now, threats we can actually look at is things like fire and water after the fire. So sometimes a small fire might break out. You actually take a fire extinguisher which is water-based, and that can sometimes create more damage as well. Smoke and particles. Now, when a fire or smoldering, there's smoke particles going in the air, and that can attach to digital tape media, and that can destroy the media. Heating, ventilation, and air conditioning, there's threats around that. It can be either breaking down and then your systems might overheat, or it can be even sabotage. Electrical power, there's threats there as well. It can go down. You can have sabotage there as well. Natural threats from our operational point of view, we can have floods, tornadoes, earthquakes, those are natural threats. And then from communication, there are little threats from a sunspot point of view. So if there are sunspots and there's certain activities during the year and it is predictable, satellite communication will be interrupted. Sabotage, also a possibility with your communication. Could be anything from satellite, laser, wireless, even cables. And often there's cable theft, which we've seen in many circumstances. Cable theft for the copper material is a threatening environment because they do get stolen. Physical access to equipment, we need to consider that from an operational point of view. Reduce risk or impact of threats resulting from unauthorized physical access. Sometimes things just disappear, and sometimes it's for the hardware and sometimes for the data, or sometimes for both. Decommissioned hardware needs to be sanitized, meaning it has to be destroyed. It has to be wiped clean, and there's certain methods and certain processes that you can follow. Object reuse is a problem. It's called data remnants. The reassignment of storage medium that previously contained one or more objects. Now, if we look at storage media, say, for example, I'm a programmer, and I, in memory or even on hard disk and so on, I write a password. But when I actually want to clear the password and write something else, I don't actually overwrite that area. And sometimes that can slip past the control mechanism and somebody can read that password afterwards. So it has to be securely reassigned, that no residual data can be available to a new subject through standard systems mechanisms. It will lead to disclosure and possibly contamination. Numerous methods are available to clear data from physical data storage, and they include things like overwriting or wiping the data. Special software exists, commercial. Also, if you can Google on the internet, DBAN or Dan's Disk Destroyer. It's a little ISO image you can create on a CD and you can boot with that, and there's numerous methods from normally wiping or even from a national security standards point of view, writing over. A degauser, physical device that actually has electromagnetic fields and would wipe tapes normally clean. This is often used from a mainframe environment and also from telephone systems, from a help desk or call center point of view, because it's very easy to do bulk erasing it actually very quickly. You don't have to format a tape. Some tapes are sensitive though and must be reformatted if the degauser is used. Physical destruction is still the best. When we look at CDs, hard drives, and also paper and so on, you have shredders that can actually shred paper, stripes, so it strips, or cross-shredding as well. Cross-shredding a little bit more secure. However, if somebody can get access to that shredded, there are special devices that you can feed it to. It scans it and has got an electronic means of reassembling the data using specialized software. CDs and DVDs, there are special machines that can shred them or just actually make holes in the CDs or DVDs. Now, when we look at misuse prevention, there are controls that you can consider. There are for personal use, staff as members working for you, and you want to control making sure he doesn't abuse the environment. So you can have an acceptable use policy, which he has to sign, of course, agree to it and sign. Workstation controls, content filtering, email filtering, etc. If you don't have adequate controls, for example, content filtering, I've seen a case in one of the countries where a staff member is suing a company for making him addicted to pornography because he says the company did not have adequate controls in place for him not to get addicted to pornography on the internet. Theft of media, we can have appropriate media controls. USB sticks shouldn't be lying around. Everything should be locked up, clean desk policy, and so on. Fraud, balancing of input and output reports, separation of duties and verification of information. And then also, for example, sniffers. Sniffers, we can actually encrypt the data on the fly on the network. And if it's encrypted, sniffers will not be able to decode that data. One of the important environments that you've seen most probably is in the cryptography or the network security, where IPsec is used to encrypt data, and it's part of the operating systems and freely available. And you can also encrypt only the the data packet or actually the whole packet. So depending on how secure you want it and how you want to protect that data. Now, records management, which is RM, there is the Department of Defense standard called 5015-02, which was done in 2007. It defines that records management is the planning, the controlling, directing, organizing, training, promoting, and other managerial activities involve the life cycle of information, including the creation, the maintenance, the use, storage, and retrieval, and disposal, regardless of the media. Also, a records manager is someone who's responsible for records management in an organization. And also another reference you can go through if you want to look at a bit more detail is ISO 15481-1 in 2001. And if we look at a little more detail in records management, Section 4 of ISO 15489-1 defines RM to include the following: setting policies and standards, assigning responsibilities and authorities, establishing and promulgating procedures and guidelines, providing a range of services relating to the management and use of records, designing, implementing, and administering specialized systems for managing records, and integrating records management into business systems and processes. Thus, the practice of record management may involve planning the information needs of an organization, also identifying information requiring capture, creating, approving, and enforcing policies and practices regarding records, including their organization and disposal, developing a records storage plan, which includes the short and long-term housing of physical records and digital information, identifying, classifying, very important here, and storing records, coordinating access to records internally and outside of the organization, balancing the requirements of business confidentiality, data privacy, and public access, executing a retention policy on the disposal of records which are no longer required for operational reasons according to an organizational policies, statutory requirements, and other regulations. This may involve either their destruction or permanent preservation in an archive. As you can see here, records management manager is really important and in a lot of scope in your organization, looking at the classification, which is really important, along with the custodian of the actual information. Then service level agreements, very important. It actually defines penalties and sometimes rewards that you can get based on the performance of the contractual obligations. Now, when we also look at continuity of operations, fault tolerance, let's first look at backups. Backups you can have full, which is a replica of all files. So it's start from finish. It's a complete replica of a disk or data set or whatever to define normally a system. We can have an incremental backup, which is backup only files that have changed since the last backup of any kind, which could be an incremental or differential. A differential backup is a backup only files that have changed since the last full backup. Now, also there's backup rotation schemes. There's first in, first out, and this is looking at tapes. So if you've got 10 tapes, we'll start using tape 1 up to 10 and basically 1 again. So depending on when they were bought and when they were placed in the actual archive. We have a grandfather, father, son. There's daily, weekly, monthly rotations. So it could be a couple of tapes of, say you have 7 tapes from a Monday to a Friday. And then you actually have a couple of tapes for a weekly, say end of week, and then end of month tape. So you actually cycle these. There's also a Tower of Hanoi, which is a recursive method. We've got 3, 4, and 5 tape. The image I'm showing you here is the 3-tape Hanoi schedule. As you can see, 3 different sets of tapes there, and when they are used and how they are used as well. And as you can see, that pyramid, because Towers of Hanoi is a game solving a pyramid tier, pyramid tower that you have to get a solution to make sure that everything is from smallest to largest. So, and 5 tape is exactly like that, just including a higher tier. We have a weighted random approach, meaning that how often we use a tape and looking at the randomization of that. So that's another approach. incremented media method. This is where, say for example, again, we've got 10 tapes, and every time we use a tape, we'll increment a number on the tape. And we will use then for the next backup a number that is the lowest and increment that number again. And when we look at all these backup rotation schemes, we can actually look at the possibility of legal hold, whereby some of the data has to be kept for possible litigation or investigations. Now, when we do backups, this is obvious, but we need to have to go through it quickly. Operation controls must ensure adequate backups of data on the system, the operating system itself, application running on top of that data, transactions, meaning that if there's any journals that has to be written as well, and the database has to be taken offline to do the backups, and each transaction that actually happens at the back end that has to be backed up, configurations of a system, because for disaster recovery or business contingency planning, and then reports as well, for obvious reasons. When we look at RAID, or redundant array of inexpensive disks or devices, I've seen numerous sources referring to any one of those. It's a backup of data on disk or devices. Can be hardware-based, which has some advantages, including speed. And the reason why the speed is better is that the controller will have dedicated processors on the RAID card. There are more RAID configurations available because software is quite limited. The disadvantage is normally is very expensive. It can be very expensive. Software-based, it's very easy to implement as an advantage, and the disadvantage is definitely slower compared to hardware dedicated and lesser configurations available. When we look at a couple of the RAID configurations, the first one is RAID 0, which is known as striping. Definitely increase of speed. However, sometimes you need to measure this if you want to, because there might be a slight overhead. So although from a theoretical point there is definitely an increase of speed, practical reasons sometimes not as much. The reason for the increase of speed is because sometimes the controller is the bottleneck of the hard drive's the bottleneck, and the controller is the bottleneck of the data throughput. So if I write 2 bytes here, 1 byte will be written to the one disk and the other byte will be written to the next disk. So you actually should have an increase of nearly double theoretically. Disk size is spanned, meaning that if I've got 2 1 terabyte drives and I'm running RAID 0, I'll have 2 terabytes in total. Loss of one disk is loss of data because it's a striping of data written to 2 disks. So I lose half the data. RAID 0, on the other hand, is a mirrored drives. The cost of the disk at the end of the day is, if I've got 2 1 terabytes, because it's duplicated, there will be a 50% overhead, which means I'll have only 1 terabyte. It allows me to lose a drive and I still have access to the other drive. Very easy to create. RAID 2 is stripes of data at the bit level using a Hamming code for error correction. This is one of the original RAID levels not being used due to the cost and complexity. Initially, what I've seen was 39 disks to be created, but lately I've seen configurations of 10 data and 4 Hamming correction for error code, so 14 disks. So as you can see, quite a complex environment and very expensive. RAID 3 uses byte level striping with a dedicated parity disk. Now, what that means, if I lose that parity disk, or I can insert another disk and it will be recreated, or if I lose a disk, it will use the other 2 disks plus the parity offset to recreate a lost disk. RAID 4, very similar to RAID 3, except instead at the byte level, it uses block level striping with a dedicated parity disk. RAID 5, the most common RAID system used very efficiently and effectively. It uses block level striping with a parity data distributed across all member disks. As you can see from the image here, disk 0 has got the parity bit at the bottom, disk 1 a little bit layer up, etc. Now, when you actually look at RAID 5, often it is the direction of that parity from bottom to top, or top to bottom, left to right, or right to left, and also the size of that blocks that created. So when you do forensics and you start looking at these things, that's important to understand that they are different implementations of RAID 5. Also, RAID is not a replacement for backups. It is for redundancy, and it is not, if you lose 2 disks in a RAID 5, for example, you'll lose your data, or it will be very difficult to recover. RAID 6 extends RAID 5 by adding an additional parity block. Thus, it uses block-level striping with 2 parity blocks distributed across all member disks. Like RAID 5, the parity is distributed in stripes with the parity blocks in different places in each stripe. Then we can have different combinations. Here, for example, we have the RAID 0+1. It is used for both mirroring and striping data amongst disks. A hard drive failure in one array can be recovered from the other array. Then RAID 10, also known as RAID 1+0, a very high reliable combined with performance. As you can see, I can have mirrors and performance at the same time. However, as you see, it is cost of disks. Now, there are different hot spares for backup devices. Now, as you can see here, an unused backup array disk that is part of the array group. There are different hot spares which remain in standby mode. We can have a global hot spare, which is linked to a device. So we'll have different groups of RAIDs, say 3 RAIDs running into a single device, but that we'll have a global spare. And then we can also have a dedicated spare that is linked to a controller of a separate RAID. Now, backup types is, of course, things like file imaging. We can have data mirroring, which is, for example, RAID 1. Electronic vaulting, that is backup of files to a remote area via connected environment. Remote journaling, so every transaction I write locally will be written to a remote system as well. Database shadowing, which is identical copies are maintained on-site and a remote site, usually via electronic means, communication links. Redundant servers or standby servers, for example, clusters. And then another item I've seen actually is RAID or tapes using a redundant array, which is normally for real-time mirroring. Fault tolerance or graceful degradation. It must make sure that we don't have no single point of failure. Also, fault isolation to the failing component, not affecting any other components. Fault containment to prevent propagation of the failure. The availability of reversion modes. And then also some technologies can be replication based on database or data, redundancy from service, or diversity. Diversity meaning that we can have multiple applications or multiple system implementation doing the same thing. Now also system recovery or trusted recovery is the correct implementation. It ensures that the failure and discontinuities of operation does not compromise a system secure operation. Now also when we look at system recovery from a failure point of view, it has to fail in a way that will cause no harm or minimum amount of harm to other devices or danger to personnel, really important, but does not cause the system to be insecure. There are 2 different ways of failure, fail secure and a fail safe. Now, the best we can describe there is if we have a fail secure, it is when the power is removed, the device is secured or locked. Fail safe, when the power is removed, the device is unsecured or unlocked. Incident management is my first line of defense. This is all to do with identifying, of course, logging, tracking, and analysis of incidents, escalation, and notification. My incident response team should consist of a few people that are dedicated and skilled for this operation. The benefits of having a response team is learning to respond efficiently to an incident, so we can actually also identify any tendencies. Priorities to business and a technical risk analysis. So if I've got a dedicated team that are skilled in this, it assists a company to actually be more productive and more secure. And finally, from an incident management, we can have root cause analysis, lessons learned. So we can actually take from this and making sure it doesn't happen again. This feeds into my business continuity management, as you'll see in the DRP and BCP. It's part of the whole process as well, part of BCM. Now, when we look at operation contingency preparations, we can have things like system failure. How do we actually prepare against that? We can have a diversity, as you see different systems doing the same thing, or same application, same results. We can have clusters, for example. You can see that in BCP and DRP. Denial of service, somebody attacking it. We can have intrusion detection, system hardening to make sure that only those services are running that should be running. We can actually also do our internal penetration testing to make sure that our system is not vulnerable to certain attacks. Tampering or intrusions, definitely an intrusion detection can be from a physical or logical point of view. Production delay, project management is a very good control there as well. I/O errors in a dispatch, for example. We can have error corrections, cyclic redundancy check, and also media access control, making sure that no errors are coming through. Change control management. One question a youngster asked me during a course like this is change control. Why do we have to do change control? It looks like such an overhead to do things, but it's a small company and so on, and didn't realize at the end of the day how you can actually make sure that things are controlled properly and the changes are adequate. No fraud can take place and no unauthorized changes. Now, it has to be integrated with business and IT initiative, of course. It sets out a change control process and ownership of those changes. It ensures that changes are reviewed for potential security impact. You will have a change advisory board, a CAB, to ensure that all changes are properly tested, authorized, scheduled, communicated, and documented. A very important fact here is that changes should be able to be backed out as well, so that all changes are, and you can add this as well, when it fails, it should be backed out. It should be a backup procedure. Now, configuration management, often within an asset management environment or assets, configuration changes are not documented. And this is a very difficult thing for DRP then to get your systems up and running, your tests done adequately. So the control of changes made to hardware, software, firmware, any documentation, test fixtures and test documentation conducted throughout the system lifecycle. That's very important as well from a configuration management point of view. Asset management, we have hardware inventory, an overview of all the hardware installed on any automated system. Hardware configuration chart, which is the detail of a configuration. We have software inventory, users that actually log onto the system, users that are actually not logging on but can be an automated user account, for example, a service account, application running on systems, white and blacklisted, what is allowed, what should not be allowed, operating system, and also configuration templates. So if you've got a mail server, a web server, or application server, how should they look like? This is all part of asset management. Also, the protection of operational files. There's system files that should never be touched and they should look the same. Often they are replaced for rootkits for people to get access to, hackers to get, or unauthorized users to get access to systems. Those should be protected at all times. Debug or maintenance programs. There's debug in the Windows environment, DOS environment. There's Zap, Super Zap in the mainframe environment, and also there are application programmers, low level, like assembler programs, which we should actually protect as well. Library maintenance, we have backups of source code and object code and configuration files. So we have to protect that, protect the source code, because sometimes the source code is the jewel in the crown for an organization. A librarian is responsible for all those documented and procedures. And sometimes the processes that goes hand in hand with that. Patch management. Problem with patch management is that there's either too little done or not at all, or too much. If I don't have a front page extension on a web server, I don't have to apply that patch. Now, there's different technologies that we can use for patch management, and the one is a push technology and the other one is a pull technology. The main difference there, a push technology, you'll have a central server that does the patch management and looks at what is out there, what should be applied, and you will push it to a remote server and then a workstation, and that will be 10-to-1 rebooted afterwards. The problem with that is that the remote system has to be switched on for it to work. On the pull side, the pull technology, in the Windows environment, you can actually look at a system of pull technologies like WSUS. The workstation itself will pull the patch that is required or authorized from the server. So the workstation, when it's on, it will do its work. So you can actually identify when it should be done for network load issues. Now, the identification of patches, process from a departmental point of view, you can go through that. Make sure that you test those things adequately, because sometimes when you apply a patch, you cannot roll it back anymore. So virtual environments are really good for this, because we can have snapshots. We can create a snapshot, apply a patch, test it. If it doesn't work properly, we can reverse back to the previous snapshot. Also, deployment challenges in rollout is my network load. So if I've got a diverse network with really low bandwidth capabilities, it may impact business negatively if I try to roll out patches during business hours. Also, if the workstation is not switched on, as we said with the push technology, it will not apply the patch. Operator privileges. Operators have got privileges outside the scope of access required. So what it means is that they can get access to company and confidential personnel data, and it's not part of their function because they are power users. So what we need to do is, when they operate on any data in the mainframe, mid-range computers, hard drives, disks, network, we need to be able to ensure that they only do the work that they're supposed to do, don't go outside that scope, and they should be monitored. So we have a couple of criteria worrying about them. The question is always, who's checking the checkers? Now, the administrator privileges is responsible for running technically advanced information systems, which includes the setup and maintenance of computers and networks. We have system administrators and network administrators. Now, one control we can have, if it's an administrator in a network environment, say, for example, your Windows domain, or which other domain, operating system, we should actually have 2 user accounts for them at least, one for normal day-to-day operations and one for administrative functions. And the reason for that is they should only log on with the administrator account or privilege account if they need to do administrative functions. If a user is logged on as an administrator and he accidentally opens an email, which you normally should have on a normal user account, and the email contains a virus, the virus has the same power as the user logged on. And that makes quite sense as well. Also, it is important to say that if an administrator wants to log on to control their access, there should be a change control process to say, listen, authorization is required to log on. Now, security administration privileges. Security administration includes the following: policy development, implementation, maintenance, and compliance. Vulnerability assessments. Yes, they have to perform hacking into the system. So make sure they have to test the security. They have to get involved. Incident response, making sure that things are closed, things are fixed. System audits and also system monitoring. It's part of their duties. Now, what do we do to control this privileged entities? We have to review access rights. This should be done at least annually to make sure that all administrators define privileged entities within an environment are still working for us, is still in the job description and so on. If not, remove them. Supervision, they have to report to a central custodian so we can actually make sure that we monitor all the actions. The monitoring, a mandate for functions should exist to ensure that the scope is limited. They should not go outside the scope. The problem with administrators is that they troll. They actually sometimes would look around at your data and see what's in another guy's workstation, just because they can. So trolling is quite a big risk, and we've seen that in organization. Any delta, changes, additions, or removals of privileged entities should be reviewed and documented as well and signed off.